Hey guys, welcome to The Secret History, Living in Your Aquarium. So today we're going to talk about wildfires and how those impact the fish in our aquariums and just ecosystems and fish in general. It really has a profound impact, and it's actually quite surprising the ways in which it changes things for the better, which is odd, and the worse at the same time. And the fact that there are two very different types of fire. So let's take a quick look at what inspired this. Usually you can see the beautiful Cascade Mountains out here and the Puget Sound. Right now we just see smoke. We have 400 parts per million of particulate matter of smoke in the air, and it is unsafe for every group is the name of the game in Seattle and a lot of the West Coast. So let's jump in on this smoky day and talk about the ways that fire impacts our forests, our streams, rivers, the rainforests, and the fish that we love so much in this hobby, as well as fish we love to eat and things like salmon and so forth. So let's talk about it. Alright, so when we're looking at a habitat that's similar to, say, a stream or creek, this could be in the jungle, it could be, tropical fish, or it could be trout and salmon in North America or Europe. However, they all behave very similarly when certain things happen. And in this tank, you'll see that the bottom of the ground, of course, when I agitate it, it kicks up all sorts of dust and sediment, as well as little planaria, little seed shrimp, all sorts of junk and mulm, as well as nitrifying bacteria and all sorts of things in there that make a healthy ecosystem. This gravel is where many, many species of fish will lay their eggs. They're egg scatterers. And this gravel, and more specifically this sediment that is kicked up, is what forms substrates. And in fact, ash is a large component, as well as soil, which is dead plants as well as stone crushed up together, is what creates soil underwater for plants and other things to take purchase. So whether it's a log washing up back in a stream, or whether it's small plants growing and then larger plants growing and then they die and then other plants grow. You know how an ecosystem works, and so this is all basic building blocks of it. Well, a lot of times the silt builds up in rivers after a fire. So it's made out of ash and other fine particles that you can see, and you can see right here how fine these particles are that naturally in a tank that's 5 or 6 years old, imagine a forest that's thousands of years old, how quickly layers of that build up and how murky that can be and all the impacts that can have. So I just wanted to show that quick little example of what can happen. But let's look at more of an ecosystem like you'd find in a lake or something like that, in a stream, the side channel of a stream. So when we talk about fires, there are two major different types of fires. And the first type of fire is going to be a hot fire that burns. It burns big trees, it burns everything in its path. It burns bushes, grass, and it burns really hot. It burns hot enough that it kills lots of animals that can't get out of the way, and it creates its own weather patterns. When you get forest fires this hot, it's usually because an area has been cleared and because an area is not in its original balance or equilibrium that it used to have. So in most forests or grasslands, rainforests even, there's an underbrush that's made out of particular things. And depending on what those things are, they burn at very particular rates. Well, the animals, including the fish in the rivers that run through these forests, have all evolved to live with the rate at which those things burn in natural lightning strike cause fires, I suppose volcanoes, and humans for several, for thousands and thousands of years as well. However, there's a second kind of fire that's much more damaging, and we're only learning the science of this fire more recently, and that is fire caused by humans in regions which have already been cleared agriculturally. So this is farmland that's gone back to seed, so to speak, that's gone back to its wild nature. This is areas where they've cleared out the old growth trees. In the west coast of America, we used to have trees 10 meters across at the base, these ginormous 100-meter tall redwood and sequoia trees. And when fires would come through, they would simply char the outside of the tree, and all the light brush underneath would burn, but it would burn quickly. So it would burn quickly and fairly hot, but it would jump across through the forest, over ridges, and then through grasslands. And it would char the grass, it would char the leaves, and it would cause, yes, ash and smoke, but it wouldn't cause things like ginormous trees to fall into rivers. It wouldn't cause the death of the trees. In fact, many pines that we see in temperate forests are designed to open and to let their cones release seeds only during fires. The bristlecone pine is an interesting one like that. And so fires are part of the ecology in Australia, in the rainforest, in Brazil, and in Venezuela, as well as in Indonesia and Myanmar, India, China, and of course North America, Canada, and the United States in particular. However, we have altered the ecosystem so much that now they burn quite differently. So let's talk about how these fires act differently, and let's talk about some of the ways that we've actually been studying fires in the last 5 to 10 years in particular very heavily, and we're learning some quite interesting things about fire and what it can do and how it can increase life in a stream or river, or how it can completely decimate it. So let's talk about the now that we know the two kinds of fires, the hot and slow that destroys everything, falls trees. The trees are gone, then you have soil erosion. The soil then goes into the lakes. Also, this produces major ash plumes, which then rain down, and just like we saw in the tank below, creates foggy conditions in the water. These types of fires burn long enough in one spot that actually small ponds, rivers, streams can get so hot that they kill the fish in the water. They can reach temperatures that warm. Whereas usually when fires would be burning through these areas in the wild, they had burned frequently enough. Small fires would burn every few years, and light brush would catch on fire because it's so flammable, and the sturdy plants would survive it because it's so fast moving. Now, people have not wanted their forests and their land to burn, and so they've prevented that. They've prevented this seasonal burn that many indigenous groups actually knew about, and they would use to enrich the soil and things. So now when we get the burns, they're very intense, and they get out of control and do far, far more damage. And in many places, like in Burma, Myanmar, as we know it now, Thailand, Indonesia, Malaysia, and Papua New Guinea, we see palm oil plantations. In Brazil, we see plantations for various agricultural goods, but we see cattle. And the locals will burn the forests using gasoline and using propane torches to start fires. And they will start giant snags. They will cut down a bunch of trees and they'll start them on fire and literally the substrate that is made up of all the fish poop and all the trees that have died over the years, and rivers move and glaciers come and go depending on the region of the world. Well, in a lot of rainforests, you get peat, and you get this thick layer, sometimes 30, 40 feet of almost living soil, humus. And this stuff will burn. It will burn like a soft wood or a light wood will. So it smolders. And so you see literally 3 to 40 times as much CO2 as well as particulate matter coming out of rainforest regions compared to temperate forest regions. And this causes, one, the release of a lot of CO2, O2, methane, and carbon, which we need in the ecosystem, but it also burns a very long time. It can burn parallel to rivers, and it causes the collapse as well of hillsides. Just as in temperate forests, the death of trees, those roots then die, and the hillsides slide down into our streams. So let's talk about a couple of the plus sides to these fires as well, before we talk about all doom and gloom, but how it really impacts our aquarium fish. So let's get into that now. Okay, so in North America, let's talk about trout and salmon, bass, perch, any sort of sports fish also that we're looking at that live in the rivers and streams in North America. So there was a study done in 2003 by a woman named Rebecca Flintcroft, and she studied a ton of fires for the U.S. Forest Service, and they thought that all these fires, these human-caused hot-burning fires, would have only kind of negative effects on the ecosystem. And while they were seeing the year that the fire happened, particularly they had 3 study sites. They had a Lost Lake fire, a Flint Creek fire, and then a Wenatchee Subbasin fire were the 3 fires they studied. And one of them was 220,000 acres in Okanagan and Wenatchee area of my state, Washington. And we usually have a lot of salmon coming up the Columbia River, and it's up that far inland, around 400 or 500 miles as the river goes, that we have our salmon start to spawn. And they need silty gravel where they can lay eggs. It's out of sight, out of mind. Them and other fish are not eating the eggs, and they settle in between the rocks and wait there to hatch. Well, these forest fires cause so much ash fall that the streams, the rivers, even big rivers like the Columbia sometimes would have foam of ash, of the light ash from these trees and fires. Specifically, a lot denser carbonous ash falls when the hot fires burn and they burn the big trees and things. We also see landslides, and we see creeks and other small bodies of water getting dammed up. And we also see snags forming. So trees will fall into the river, and usually we get in the fall and winter we have windstorms here. And what I'm saying about this is really a story that holds true for the rainforest, for all the fish in our hobby. So when those things fall into the river, they actually create fish habitat. And while it is possible that sometimes they will completely block a stream and that will ruin the way salmon spawn, quite frequently what they'll do is they'll dam it for 5 or 6 feet, and they will kind of create rapids or little retention ponds or holding ponds so that the salmon can swim upriver and then wait, and they don't get as tired. They don't have to go against a completely unfettered raging river the whole time. And this is true in the Amazon too. Not that the Amazon goes up an incline like that, but these snags really produce a lot of habitat for small fish. They, in Africa, for instance, in Central African Republic, where they get these big fires as well that burn from lightning strikes, they'll get, a 200-foot tall tree will fall into the river and float down something like the Congo River, and it will lodge in, and then silt and dirt will accumulate over years, and plants, beautiful plants, grow there. Anubias, and in Southeast Asia you get Bucephalandra, you get Java ferns, Java moss, all sorts of things growing on these snags. This is what creates those trickling streams and those tributaries where so many of our fish are found. So these fires are really crucial. However, when they're burning at such a hot heat, the problem is when you've slowed down that water, naturally, this is what happens with natural fires too, is you literally can cook the fish as the fire burns across the stream. You can also burn that subsoil layer that in the tropics is very common. And a lot of times in the dry season versus the wet season, there's actually eggs as well in the muddy or somewhat saturated soils, things like killifish and things of that nature, and other little cyprinids and things, mud pups, things that can survive with very little water, and labyrinth fish, for instance, bettas and licorice gouramis, they can survive in very little water with low oxygen. So not so much the ash bugs those fish, but they cannot be cooked, obviously. And that's what's happening. And then what happens is they have a big cleared field, and they'll come in and they'll plant monocultures of plants, and basically it completely throws off the ecosystem of, over time, these little fires should be adding little bits of nutrients over time. But instead we get these huge dumps of nutrients, and then we get giant algae blooms. And these algae blooms can actually take so much oxygen out of the water along with the silt that the visibility's different, the oxygen level's different, there can be harmful algae blooms. It goes out into the sea, and it can cause, deadly algae and bacterial blooms as well, because primarily what's getting released is phosphorus, nitrogen, and carbon, of course. Now we need carbon, that's the building block for everything, and nitrites and nitrates are going to be what our plants need too. And phosphorus, for that matter, regulates our plants and how they metabolize things underwater and above water. And CO2 we can use for plants to convert into energy as well. That's where they get that's how they build mass from the atmosphere. That's how, if you've ever wondered how a little plant on a rock up on a mountain turns into something out of nothing, it's because the water and the air have carbon and nitrogen in them, and those form bonds and they build. I mean, they're not necessarily pulling energy and material to build their own cells out of the rock. Some plants do that somewhat, but that's not the primary way. They're using photosynthesis and CO2. So speaking of that, when we get these big fires and the air is so smoky, it completely throws off the wavelengths of light also. And this can cause rivers, lakes, oceans even, to change temperature. These ash plumes travel around the world. And so really what we're learning now by studying these fires over time is that yes, fires are good in moderation. However, when we don't clear the debris in our forests, they burn very hot. It may be harder for them to get going, but once they do, they are going to burn very hot, very long, hard to put out. They'll burn right underground in the tropics into that layer of humus. And not hummus like you eat, by the way. So that's just one of the really bad side effects of it. However, when we get the erosion from these things, which the little fires that are natural that would burn across most of the world quickly every dry season, they would cause an occasional tree to fall. But most of the trees on a hillside would still live through it. They'd live through most of these fires, they'd get charred, and then they'd go on living. And because of that, their roots would stay within the hillside, or even if they died, they wouldn't burn bad enough that it would burn down into a stump and compromise that integrity structurally of the hillside. And so after time, you start getting iron and manganese, particularly in the water. But when we see these big fires like the ones in California, the ones in the rainforest for clearing for palm oil or for cattle farming, as well as gold mining. Another odd one that you may not think about is MDMA, ecstasy, is the illegal drug, is made out of these trees called saffron trees, and people will burn down chunks of the forest to try to get at these old trees, and they actually burn a lot of other material, including that peat moss or humus, to heat their stills to cook it down. Same thing with gold mines and silver mines and smelting and melting down things. You know, they'll add gasoline to the logs and things, but they'll use that to actually burn fires. And this puts off all sorts of awful toxins into the air, let alone when they're spilling gasoline onto the soil, or petrol onto the soil. It soaks in and you get benzene and all sorts of terrible things that will last for thousands of years in some cases. So it's kind of interesting that life naturally needs these fires. The manganese and the iron in small amounts is great for the fish, it's great for the plants, but in these big amounts, it can't take it. And really, fires are like everything else in life. In moderation, they're okay. But the way we currently manage them in most parts of the world, which is to say either not at all, or we have cleared out these keystone trees that are very large for lumber and other things to clear for agriculture, those are the walls, the fortress that really slows down the fire, or that it can burn right past because they won't catch. They have enough mass and water in them, even in the dry season, that they just won't catch. Or the outside of their bark will burn, like on cedars. And it's things like this that when we don't have the moderation, that silt in the water, the silt in the sky, we're seeing as much as 7 degrees difference in rivers in Washington state. Imagine in a rainforest that gets to 115 degrees and humid. You can see major changes when you get rid of that entire tree canopy and you're cooking the fish in that stream. It doesn't take a fire to kill fish in that case. You can kill whole streams, you know, things like rainbow fish, where they're oftentimes, or gobies, where they live in one river system. A large fire can make them go extinct completely. It can also dam things off, and it can also cause speciation over time, because they'll become a river possibly behind one of these, or a lake behind one of these rivers, and then you get all sorts of evolution, like in Africa. I'm not saying forest fires caused the Rift Lakes to form, they didn't. But my point being that when a lake does form, over thousands, hundreds, and sometimes even shorter than that, if you've watched my stickleback videos and sunfish videos, changes the way fish evolve, the way they live, the way they utilize their gills, their armor, and their coloration. It's all affected by this, because different wavelengths of light go through the water with different clarity levels. They can breathe much easier in water that doesn't have ash dissolved in it, of course, than when it does. They can oftentimes die out from being choked out from that. So the other thing that these natural fires take care of is rotten trees, scrub brush, and they're just dumping small amounts of these nutrients that we need and causing seasonal algae blooms every few years. But a study done in Alberta by a man named Oldis Stillins out of the University of Alberta in 2003 found that the year following a fire, the fish in the rivers had 20% more fat reserves on average, because and their population had increased, really depended on the species, from not much of an increase, marginal, to all the way to double the amount of fish after a serious forest fire. And this is up in northern Canada, where there has been no logging of the undergrowth. So this is a natural forest operating the way it should, just like the deep rainforest does. And they compared that with fires that have burned in areas in North America, in southern United States territories. So like that Wenatchee sub-basin fire that I was talking about, that was being studied. They then went back and looked at the data, and they counted the fish in the following years, and they found that their fish populations had actually decreased when we have these hot burning fires. So really we need to advocate for sustainable practices, not burning and torching the forests for agriculture, for cattle, for palm oil, and we can make a difference in that, in what we buy. But also we need to encourage not having monocultures in our forest where they replant all just one tree, and they're small trees that grow fast. For instance, down here we get a lot of birch and alder and poplar being planted, or oaks and maples, whereas there were dozens and dozens of species naturally, plus there were all sorts of shrubs and grasses, and those should burn first, burn hot, and then get out of the way, and release enough of those chemicals to help the fish and the plants, which definitely do need fires. It's part of the natural system. It's how soil is made, one of the main ways, other than erosion. But it is very important that we start thinking about these things, because we're running out of untouched forests, and it takes hundreds of years to get a forest back the way it should be, the way that ecosystem evolved for millions of years up to this point to exist, or if there was a glacier in the way, thousands of years. But the main thing that I hope that you guys take away from this is that we can make a difference in it, and that while we see all this stuff in the air and things, it may be very detrimental to the fish right here, but this ash will fall around the world, and it will add phosphates, it will add nitrates, it will add carbon to rivers, lakes, and the ocean. And this is part of how the world renews itself, is through fire, a cleansing through fire. And I just really hope that people will take an interest in this. You'll write your local senators and congressmen, local officials, and let them know that you care about how the forests are managed, because it's not just our aquatic species from the tropics that we should care about. You know, we've got a very, very beautiful local population all over the United States, Canada, Europe, of fish indigenously. And many of the coolest fish, like the elosoma, the pygmy sunfish, or the devil's hole pupfish, many of these fish only are found in one river or one lake or one basin. And one severe fire can ruin all of that and make them go extinct. And we still haven't even discovered all of what's out there. So I hope this video was a little bit enlightening on what fires do, both positive and negative. It's really a mixed bag, and a lot of the things sound positive, but it's all in moderation. And so the key is to have these natural fires that burn semi-annually, rather than massive fires every 10, 15, 150, whatever, large amounts apart years. And if we can help prevent these regions from being developed for things like palm oil that we pay pennies for in the West, we can make a large difference in the amount of slash and burn that goes on in this area. You know, the Aborigines and the Native North Americans knew to burn the forests and the fields annually or semi-annually. And they knew these effects that it had. They knew how they could get more fish and how they could have more fertile soil, how they could get nitrogen in depleted soil. And it's all part of a cycle that's very important. But we need to get back to our roots and understand that, and bring new technology into the field, as well as consumer information and being informed. Now you don't have an excuse if you made it this far, to check into what you're buying. If it has a bunch of palm oil sourced in rainforest regions, you know that area was slashed and burned. And it's not good for those creeks and rivers there. They're probably gone where that palm oil came from. So I just hope you guys think about that. I hope you guys stay safe in the fires, both from the fire itself, but also from the smoke and the health hazards from that. And just think about how the world is connected to our aquarium. If you enjoyed this, if you like this longer form content, please check out my Patreon page. I'll try to post some source material links there to interesting studies about forest fires and things like that. Also below, you can support the channel through my Teespring, which has art of fish on shirts. I don't do any branding of my channel. It's just fish and artwork, illustrations. So you can check that out if you find that interesting. And of course, please like and subscribe if you liked it. If you didn't like it, give it a thumbs down so I know not to make these long diatribe videos about fire and ecology. But it's all important and it all ties the world together. So thanks for tuning in. Thanks for being tied together with me for a moment. And I'll talk to you guys later next time on this secret history living inside your aquarium.